Good evening, viewers. It's June 25th, 2019. What we have for you today on the bench is the hybrid battery pack from a 2003 Prius Classic. This is the ugly Prius, not that they have any pretty ones, but it looks very un-Prius-like. But in any event, this particular car, 2003, has about 225,000 miles on it. And I've been told that these hybrid battery packs might go to 250, and that's about it. So we pulled the battery as a precaution, and first thing I want to mention is that safety first. Safety plug has been removed, so that reduces the voltage that's able to be accessed. The cover is off, as you can see, and the protective covers for the terminals of the 38 modules have been removed. Now each module is exactly 6 cells, nickel metal hydride cells, and they are nominally rated at 1.2 volts, so and 6.5 amp hours. So basically we have these batteries connected in series. 274 volts is available at that nominal voltage. Now the first thing I noticed when I pulled this battery cover off was significant corrosion. I've got a light on here, as you can see. And this caused me great concern initially. So I went and I tried to find a vendor to replace this battery pack with a remanufactured one. Long story short, it was a complete disaster. I ended up with a damaged battery in shipping and very poor quality workmanship. As far as I could tell, they just pulled it out of a junkyard and shipped it to me. So you can find lots of videos on the internet about how to rebuild these batteries and some questionable ideas about processing the battery to recondition it. But here's the bottom line. It's fairly easy to pull the cover, put a voltmeter or multimeter across every terminal of each module, and get a reading of the open circuit voltage. It's also real easy to put said multimeter across the terminals of the batteries, and that's what I did. And despite this severe corrosion, I didn't see any battery less than 0.3 of an ohm, exactly the same resistance as touching the multimeter leads together. So despite the exterior corrosion, it doesn't mean that you have high internal resistance across those terminals. So when I discovered that, I decided to go to step 3, which was to document a small load test using a light bulb and a timer. And I went through every individual cell, initial open circuit voltage, the final open circuit voltage after 2 minutes, the watt hours, and the amp hours, and then the immediate open circuit voltage after that run was done. Now, what I found was that the problem child is cell number cell number 16, this one here. From the get-go, this cell had about 1/10 of a volt lower open circuit voltage than the rest, and it's in the middle of the battery pack, which gets hotter, so it's a bit of a problem child. So what I've got here is a $15 True T RC load meter, and it's counting up as I'm charging from a 9-volt source. I went from 7.34 volts to 7.6. So what we'll do is we'll do a load test. We'll pull a couple amps out of it, maybe only about a half an amp. I'm not sure what charge rate to discharge at, but it will be less than 1C. And we'll see if it has a capacity of 4,000 milliamp hours. If it does, I'm going to throw this cover back on and put her in the car and drive her till she drops. So hope you found this of interest. In summary, if you have an older Prius and are debating whether to exchange it for another battery, I'd recommend pull the battery yourself and take a quick look at it. Check the open circuit voltage, check the resistance across the terminals, and if you find a suspect cell, do a load test. And be very careful about going to a third-party shop. The ones I've dealt with won't tell me what they do, they won't give me a test report, and they look kind of sketchy. So hope you found this of use. Feel free to leave comments or questions in the links below. Thanks.